Hi everyone, welcome to the 87th session of Python for Machine Learning. In this session, we will learn how to manipulate R-square. R-square is the matrix which is used in linear regression to calculate the accuracy. So we will learn about the scenario where we will have the R-square value which will be tends toward 1, the value of R-square which will be equals to 0 and where R-square will be less than 0. So the first scenario in which R-square will tend towards 1, it will generally imply that the residual sum of square by sum of the square from the mean is equal to 0, and this will imply that residual sum of square is equal to 0, and this is the case. Residual sum of square is nothing but my summation of all the points from the actual value minus the predicted value and the difference you take and then do the square and sum all the points. So and we will make this equal to 0. So this will be the case where if I say summation of yi minus y hat whole square is equals to 0. So what does this mean? It means that y1 minus y1 underscore hat whole square plus the second point minus its predicted value plus the third point minus its predicted value plus dot plus again the nth point minus its predicted value is equals to 0. So what do you think? In which scenario this will be the case? This will be the case when my y1 is equals to my y hat, y2 is equal to y2 hat, y3 is equal to y3 hat, and this means my actual value and the predicted value is the same. In that case, this will hold and my value of r square will be 1. So what I will do, I have taken a point and I am just plotting it this value. And please note, before in order to understand this code you need to watch the session number 86, then only you can understand how we have derived and how we are taking the dot product and getting the value of this slope and intercept, and then how we are doing the entire code, how we are writing. So what I'll do, I have taken the value of x and y and then I'll plot this. So you can see my actual value and the model predicted value is the same here. And if you see what is my y hat, y underscore hat. So see my predict actual value is 0, 1, 2, 3, 4, 5, and my predicted value is nothing but my y hat. We're using this model, using this slope and intercept. So in that case, the scenario when the actual value and the predicted value is same, then the value of r square will tend toward 1. So in this case, if we evaluate this, the value will be 1, and that is what we have got. Now the second scenario where we have the square is equal to 0. In this case, r square is equal to 0. It will mean that 1 minus residual sum of square by sum of square from the mean is equal to 0. And if you solve this further, it will mean that residual sum of square which is equal to sum of square from the mean, and residual sum of square is nothing but the difference of all the point from the predicted value, difference of the point, the actual value minus predicted value. You take the sum of all the points, and this should be equal to sum of the point from the mean. And in which scenario this is possible? So we'll go here, we'll take this. Okay, this should be equals to y1 mean y mean, okay, y2 minus y mean, this is equal to y3 minus y mean, this is equal to yn minus y mean. And so if you see there, y1 in all the, suppose you have n number like 6 points. So before this left hand side, before the equal to, the left hand side and the right hand side will take. Okay, so y1 y2 y3 will remain the same, and if both the side has to be equal, then this y1 hat should be equal to y mean, y2 hat should be equal to my mean, y3 hat should be equal to my mean. In what condition this will be possible? This will be possible only if my predicted value is my mean, and then that is the model will be like in that case. So what is my mean here? Mean of 0, 1, 2, 3, 4, 5, 6 is 3, right? So if we say 3, 3, 3, 3, 3, and if we execute this, so this will be our model. This is my point and this is my model. So this will be not bad, but still it is bad, like when it compared to the case when you have the r square value as negative, and we will we will work with it shortly. So I hope you have understood the first two same scenarios where the r square value tends towards 1 and the r square value is equal to 1. The third case where r square is less than 0 means 1 minus residual sum of square by some square from the mean is less than 0, and ultimately what we can say, residual sum of square is greater than sum of square from the mean. And further, if you uh, if, if you take this residual sum of square, so from here it will mean that my y hat, all the predicted values like should be greater than y means. This is one of the, like, you can decode from this equation, because ultimately y1 y2 y3 in both the sides remain same, and from this we can make out that the value of y hat, or so residual y hat will come with residual sum of square is greater than my sum of the square. This case I will execute, I'll show you how to execute this. Suppose this is 6 5 4 3 2 1 0. Now we have our model. What is this? Is a number currently, and this is our point. Okay, now what we will do, this is my actual value 0 1 2 3 4 5 6. What we'll do, uh, though we know that if we give 3 for all the points means our predicted value is our mean, the value of r square will be 0. Now the case where we are predicting even the worse than the mean, like the mean is 3, and we are predicting 6 5 4 3 2 1 0. So we are the cases where we are even predicting worse than the mean. In that case, how will be our, so this is my actual points, and what I am predicting is the exact opposite of my points of my model. So in that case, my r square will be negative, and if you can see the r square value, it need not be exactly like opposite, but it has to satisfy the condition where the sum of the square of the residual is greater than the sum of the square of the mean. In that case, the value will be negative. And also please note, this does not mean that the correlation, like if the fields are negatively correlated, the r square will be negative. No, if I say something like if we give here 6 comma 5 comma 4 comma 3 comma 2 comma 1 comma 0, my value of 6 is if my value of x decreases, y increases, and the vice versa. So even in this case, my r square will not be negative, it will be positive. It will be positive one. Why? Because my actual value and the predicted value is same in this case also. Only the case, in this case, what we do, if we make the, now in this case, if we create like this, oh no, sorry, in this case, if my actual value and predicted value, okay, so this line dots are my actual value and this line is my model, the predicted value. In this case also my r square will be negative. So thanks a lot for watching this session. So in this session we have learned three things. First is the value of r square where it will be negative. No, no. So in this session, like before winding up the session, I just want to recap what we have learned. The first thing we have learned is how the r square, what under what circumstances r square will tend toward 1, r square will be equals to 0, and r square will be less than 0. It's the negative. So I hope you have liked this session. Thanks a lot for watching this session. If you feel this video is helpful, please press the like button and subscribe to this channel. And I will see you in the next video. Thank you.